Hello everyone, and welcome back to my channel. This is Vishnu Manjipudi, and I'm glad that you are all here. Today, we will be solving problem number 118 on LeetCode, Pascal's triangle. The problem reads, given a non-negative integer num_rows, generate the first num_rows of Pascal's triangle. So here you can see a visual demonstration of Pascal's triangle, where in each row, you always have a string of ones on the left side and the right side. In the middle, you add the two adjacent above tiles. So for example here, 1 plus 3 equals 4, 3 plus 3 equals 6, 3 plus 1 equals 4. So for example, if it's 5, the output is 1, right? 1, 1, 1, 1, 1, 1, 2, 1, 1, 2, 1, 1, 3, 3, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1, 1, 4, 6, 4. So the way I'm going to do this is I'm going to actually create a function that generates each row, and then I'll execute a while loop in the original method that adds on each row to a list of a list, and then return that list. So we have to first create a list. So p try equals new array list integer, and then yeah. So now let's create a new method. So public list, because we want to return one list of the row. So integer row gen equal and then now what do we want as input? We want the previous row, right? And we also want the number of that row. So we'll have int num row, comma list integer prev row. Okay, so now let's begin. So we want to first create a new list integer. So list integer cur row equals new list array list. You can't define new array list integer. Okay, and now we want to do cur row dot add 1, because 1 would be the first number in that. So now let's add a for loop, right? So for each element, like 0, 1, 2 in a row, so for int I equals 0, I is less than 2. So this is row number 3, and we want to add up till element 1 here. So I is less than num row minus 2, I plus plus. We actually, since it's less than, we only need a minus 1. Okay, and then we do cur row dot add. And now what do we add? We add the sum of the number of index I. So prev row dot get I. And we add that to prev row dot get I plus 1, right? So prev row dot get I plus 1. Okay. So now at the end we have to tack on another 1, right? So cur row dot add 1. And now we have cur row, so we just return cur row. Now what do we call in the main method? So we want to create our own array list, prev row, right? So list integer prev row equals new array list integer. And we want to add 1 because the first row is 1, right? So prev row dot add 1. And then we want a for loop actually, right? Because we want to know num rows. So we have for int I equals So number, we want it to be 2 because we actually, int I is equal to 1 because we already have the first row, and then I is less than num rows, I plus plus. Now we want to first add the prev row, right? So prev row, and now here we want prev row equals row gen I, comma, actually we probably want a 2 and less than or equal to I, comma, and then we want prev row, right? And then we want p try dot add prev row. And now we should have our Pascal's triangle. So we just return p try. Now let's test this on test case 1. So according to this diagram right here, test case 1 should yield 1. And let's see. Accepted. So yes, it did output 1. Now if we try 2, it should be 1, 1, 1. And index out of bound exception. So let's see what went wrong. I see. So if I is less than numRow minus 1, then we want to use prevrow.size, not numRow, right? Because otherwise it will be out of bounds. So yeah, we want that. Which means there was no point taking in numRow. So we don't need that, we just need prevrow. And accepted, we had 1, 1. Let's try 5 this time. We should get a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 1. Accepted. And now that we are confident in our answer, let's just run a larger test case like 15 to make sure that it handles larger cases. It should, because it only uses array lists. And lo and behold, it does. So now that we're ready, we can submit. And wrong answer. This is because we have not accounted for the case where numRows is equal to 0. So what do we do in this case? We just put if p try numRow equals 0, return p try. Okay, now let's run our code for 0. These edge cases in these coding problems are generally what trips most people up when they do these problems. So it's always important to check edge cases before you submit, unlike we did there. So now that we are confident, we can submit. Runtime 0 milliseconds, faster than 100% of all Java online submissions for Pascal's triangle. And memory usage 37.2 megabytes, less than 6.02% of Java online submissions, which means that we have completed this problem, and that would be the end of today's video. Thank you all so much for watching. It really means a lot to us. Please don't forget to like, share, and subscribe, as well as if you have any questions, comments, concerns, or any other requests, please comment down below. Any thoughts or ideas would be greatly appreciated. Also, once again, thank you all so much for watching, and this is Vishnu Manjipudi signing out.